Hello, and welcome to this section where we'll cover the fragment lifecycle. Similar to activities, fragments have their own lifecycle, which have associated callbacks for needed setup and cleanup. Here we see the general flow of the fragment lifecycle, which draws a striking resemblance to that of an activity lifecycle. We have the same named callbacks for onCreate, onStart, onResume, onPause, onStop, and onDestroy. Similar to an activity, after the onResume callback is called, the fragment is active and presented to the user. Since the fragment is a subview of an activity or a screen, there is a necessity for some additional callbacks. These callbacks also allow us to create a standalone UI component that can easily be used in multiple screens or aspects. The onAttach method is called when the fragment has been associated with an activity. The activity is also passed here. The onCreateView method is called to create the view hierarchy associated with the fragment. This is normally when the layout associated with the fragment can be inflated. This method requires a return type of a view so that the inflated layout can then be returned to the associated activity so that it can display the fragment in the activity's UI screen. The onActivityCreated method is called when the activity's onCreate method has returned. OnDestroyView is called when the view hierarchy associated with the fragment is being removed. And finally, onDetached is called when the fragment is being disassociated from the activity. To get a better look at how the fragment callbacks line up with the state of its associated activity, we can see here the activity state for each segment of fragment callbacks. The onAttach, onCreate, onCreateView, and onActivityCreated fragment methods are called during the activity state of being created. The onStart method callback for the fragment is called during the activity state of being started. Similarly, the onResume method callback of the fragment is called during the resumed activity state, and the onPause and onStop during the paused and stopped activity states respectively. Finally, when the activity is being destroyed, during the destroyed activity state, the onDestroyView, onDestroy, and onDetach fragment callbacks are called. In many cases, we may have more than one fragment in one activity, and it could be important for communication to occur between those two fragments. Let's take a look at how these fragments can communicate between each other. In this section, we will take a look at how it is possible to communicate between different fragments within the same activity. In addition, how to communicate between the host activity and its children fragments. When creating an activity that contains fragments, it will often be needed to communicate with these fragments from the activity or between the fragments themselves. In this illustration, we have outlined an activity, activity A, that contains two fragments, fragment 1 of class fragment 1 and fragment 2 of class fragment 2. For this example, let's assume that both of these fragments were added via the XML layout for the activity, instead of being added dynamically through the Java code in the activity. Let's assume that fragment 1 is listed in the layout XML for the activity with the ID fragment_1, and fragment 2 is listed as fragment_2. If we would like to access fragments from the activity level, we can acquire the fragments through the fragment manager, in a similar fashion to how we have acquired views in the past. We can access the fragment manager from the activity by calling the method getFragmentManager. Once we have the fragment manager, we can acquire one of its fragments by calling findFragmentById with the fragment ID, or in this case, the first fragment would be r.id.fragment_1. Please note that in case we are using fragments from the support library, in order to have backwards compatibility, we would need to call getSupportFragmentManager instead of getFragmentManager. Accessing the activity from the fragments is even easier by utilizing the method getActivity from a fragment, which will return the activity the fragment is currently associated with. Once we have accessed the activity, we can access other UI elements and other aspects of that activity. In this fashion, we are able to easily communicate between the different fragments within an activity. There are also several other methods to implement the communication, which we'll see some of later in future examples. Since both fragment 1 and fragment 2 have two-way communication with the activity, we can then pass messages through the activity to each fragment, as we see here in this diagram. For instance, if we have a user click event in fragment 1, and that user click event requires us to change the content in fragment 2, we can notify our activity and have our activity notify fragment 2 that it needs to update its content. Now let's take a look at how to implement fragments and similar procedures in code in Android Studio. In our fragments example, we have created several activities for an application to showcase how to utilize fragments in Android development. The first activity we will look at is the main activity, which we created through the new menu option by right-clicking on our package folder. Then selecting New Activity, Blank Activity with Fragment. We see here that the Activity Creator form suggests Main Activity 2, because we've already created our main activity. It is important to remember to check the Launcher Activity checkbox if we'd like this to be our launcher activity, and fill out the rest of the remaining data as is pertinent. We can see in the activity main XML that there is no listing of the fragment. That's because the fragment is generated in the activity code itself, so let's take a look there. We see here in the onCreate method that some code has been auto-generated for us. In particular, in the onCreate method, the support fragment manager is obtained by calling the getSupportFragmentManager method. The support fragment manager allows us to utilize fragments in Android APIs below Android 3.0.x. Then a transaction is started and a placeholder fragment is added to the ID container. We can see that the placeholder fragment class is defined inline and implements the onCreateView method where it inflates the layout fragment main. This was all generated for us when we selected to create a new blank activity with fragment. Let's jump into the fragment main XML and see how we're going to generate that fragment. We see in the layout for this fragment we have a button inside of a relative layout with the onClick callback of button click. If we Control plus click the function, we can see its implementation. When the button is clicked, we create a new intent to the toFragment activity and start the activity. For the toFragment activity, we create a blank activity without the fragments and add the fragments individually ourselves. We can notice that there is another package within the default Java code package. This is where the fragments are stored and all the other classes related to them. Just as easily it was to create a blank activity, we can create fragments just as easily by right-clicking on the new package and selecting New, Fragment, Fragment Blank, or Fragment List. When we create two fragments, Fragment 1 with XML layout Fragment 1 and Fragment 2 with XML layout Fragment 2. Notice that there are options to include fragment factory methods and include interface callbacks. For this example, we have unselected those when creating our fragments. Now let's take a look at the XML layout for our toFragment activity. The XML layout activity toFragment.xml. We see that we have defined two fragment elements inside of a linear layout. Also notice the usage of weight sum of 5 and a layout weights of 2 and 3. And the definition for these fragments defined in the Android name attribute. This will allow the first fragment to take up the first 2/5 of the screen in width, and the fragment 2 to take up 3/5 of the screen in width. Note that the width of each fragment is set to 0 dp. This allows the calculation to be made by the linear layout to measure the system accordingly to attribute 2/5 to the first fragment and 3/5 of the width to the second fragment. Now let's take a look at the Java code for this activity. We see that this activity implements a custom interface called Fragment Message Listener, but we'll get to that more in a second. First, let's take a look at the onCreate method. In the onCreate, we obtained both of our fragments and reference them to members of this activity. First, the mfrag1, which we referenced to the first fragment, or frag1, and the mfrag2, which we reference this second fragment, fragment2 or frag2. This way we can manipulate the fragments later on in the code. Now if we notice, our fragment message listener, which is defined in the frag package, has a counterpart, the fragment message receiver, which is also defined. These two interfaces will allow us to communicate between our fragments and our activity. So let's take a look at the fragment message listener now. We can see that we have a simple edit text that receives a number and below that a button. The goal is that the user can enter a number, press the button, and then the content in the second fragment will change. So let's take a look at the UI now for the second fragment. In the fragment2 XML, we have the UI for fragment2 that consists of 4 buttons. These buttons contain no text, but once a number is sent from fragment 1, the buttons will contain the number of that number sent and consecutive 3 numbers afterwards. Let's see how this is done in the fragment code for fragment 1. It is important to note that we changed both this fragment and the second fragment to extend Android support v4 app fragment. This is to allow for backwards compatibility. Originally, when they extended the fragment class, they would only be compatible from Android 3.0.x and above. In fragment 1, in the onCreate method, we had played our XML and obtained the button and edit text, as well as set an onClick listener for our button that calls the mMessageBridge method on message to fragment 2. If we look at our onAttach callback, we receive as a parameter our activity, which is a implementer of fragment message listener. So we can reference our mMessageBridge to that activity. Now we can easily send messages to fragment 2. In our onMessage callback of fragment 1, which implements the interface fragment message receiver, we set the text of our edit text to the number sent from fragment 2. This is the number clicked on the button, and we will reset our edit text to that number. Now let's take a look at our second fragment. We see in our onCreate view of fragment 2, we obtain all 4 buttons and set an onClick listener for each one. Similarly in onAttach, we cast our activity to an mMessageBridge reference. Here we see the implementation of our onClick method. When a button is clicked, we send the text from that button to our MessageBridge onMessage to frag1, so that fragment 1 can receive that message. When a message is received to our activity on our callback onMessage, we parse it to an integer and set each button to the appropriate numbers as previously described. Now let's look at our activity and see how it routes the messages. We see here that the call is made to onMessage to frag2. We route the message to our second fragment. And when the call is made to onMessage to frag1, we similarly route it to our first fragment. Now let's run our application and see how all of this ties together. We see our launch activity with a blank fragment with a single button to open our 2-fragment activity. This fragment was created by our new activity wizard with a fragment already set inside the activity. Now we press the button to open our 2-fragment example. We navigate to our double fragment example. Here we see on the left in orange the fragment 1, which takes up 2/5 of the activity, and on the right the fragment 2, which takes up 3/5 of the activity, not including padding, as we declared earlier in our application. Now if we enter a number in our edit text and we press the send button, it will send that number to our second fragment. And here we see it also add all the consecutive numbers 6, 7, and 8 to the original number of 5. Now if we click one of the numbers in our second fragment, we see that that number is transported back to our first fragment via the tunnel bridge that we built earlier between our fragments and our activity. Thank you for joining us in this deeper look into fragments. Please join us in the next video where we'll cover the lab exercise for this section.